Hello future engineers and my dear students, welcome back to Mudus Academy and I am Mudus Sheikh. In the previous video, we derived an expression for radius of curvature for a Cartesian curve, and in today's session, we are going to solve the problems on the same. That is, we are going to solve some exam related problem based upon the radius of curvature for a Cartesian curve. So keep watching till the end and keep practicing, and if you are new to this channel, then do subscribe to stay ahead in your studies. So let's start solving the problems now. So let's start solving the problems. The first problem we are going to discuss here is find the radius of curvature for the folium of Descartes x cube plus y cube is equal to 3axy at the point 3a/2, 3a/2 on it. So as you've seen in the derivation, we derived the relation for radius of curvature as rho is equal to 1 plus dy by dx whole square whole raised to 3/2 upon d square y by dx square. That means you need to first find dy by dx, put the points on it. Then from the dy by dx find d square by dx square, again put the points and put in the formula to get the radius of curvature for the Cartesian curve. So let's start solving this problem. Okay. So we have, as you know, first we need to find dy by dx. So we'll have this curve. The curve is x cube plus y cube is equal to 3axy. So differentiate this with respect to what? X. So differentiate x cube is 3x square plus y cube is 3y square. So differential y cube is what? 3y square into dy by dx equals 3a into x as it is dy by dx plus y as it is into 1. Am I right? Now, to find dy by dx, we need to group the dy by dx terms on the left hand side and everything on the right hand side. Okay, so we'll find it as, so what I'll do, I'll open this bracket here, that gives 3ax dy by dx plus 3ay. Now, bring all this dy by dx term this side, so we have dy by dx into 3y square minus 3ax is equal to 3ay minus 3x square. Therefore, we have dy by dx is equal to 3ay minus 3x square divided by 3y square minus 3ax. So now since 3 and 3 is common here, so you can remove it, we can cancel it out. We have dy by dx as, that implies dy by dx is equal to ay minus x square divided by y square minus ax. Okay, so we have found dy by dx for this term. Fine. So as you have found dy by dx here, next thing we need to find dy by dx at the point 3a/2, 3a/2. It means in place of x put 3a/2 and y put 3a/2. Let's put it here and find dy by dx at a point 3a/2 and 3a/2. Now, dy by dx at the point 3a/2, 3a/2 will be, in place of y put 3a/2 and x put 3a/2. So, a into 3/2 is 3a square by 2 minus 3a/2 whole square is 9a square by 4 upon y 3/2, that is 9a square by 4 minus 3a square by 2. So if you see it clearly, it cancels off to give us how much? Or if you solve it, okay, I'll solve it for you. We have the LCM is 4 here. So to 6a square minus 9a square whole divided by, again LCM is 4 here. So we have 9a square minus 2 to the 6a square. So cancels. We have minus 3a square by 3a square. So we get dy by dx at the point 3a/2, 3a/2 is equal to how much? Minus 1. So we have already found dy by dx at the point 3a/2, 3a/2 is nothing but minus 1. Now we need to find d square y by dx square using this dy by dx and again put the points on it. Okay, so let's find d square by dx square. Now see here, to find d square by dx square, there is division. So that is first function upon second function. That means we need to apply the quotient rule of differentiation here. If you are not forgotten quotient rule, I'll give simple formula here to find the quotient rule. The quotient rule formula is, let's write here, say d by differentiation of first by second function. So differentiation of first by second function is equal to, keep the second function square, second function as it is, differentiate first function, minus first function as it is, differentiate second function. Very simple formula to remember. Now if you use this formula to differentiate here, so what we can do, d square y by dx square is equal to, we have d square y by dx square is equal to, denominator, see this, denominator square, y square minus ax square. So we have y square minus ax square. Then second function, denominator, second as it is. So y square minus ax as it is. Don't forget to put a bracket. Into differentiation of first function. Who is the first? Ay minus x square. So a as it is, differentiation y is dy by dx minus differentiation x square is 2x. Next, first function as it is, ay minus x square as it is, minus ay minus x square as it is. Be careful about the sign. There's a minus sign here because many people get confused here in solving differentiation of quotient rule. The sign is what? Minus here. Don't forget. Okay. And what I told? I told first function as it is, differentiation of second function. So y square will be 2y dy by dx minus differentiation of ax is minus a. Okay, so we have this differentiation here. Now the next thing is we need to find dy by d square by dx square at the point 3 by 2 comma 3 by 2. That means in place of x you put 3 by 2, in place of y you put 3 by 2, and we already know dy by dx is nothing but how much? It's minus 1. Okay, so let's put all that thing here. So that implies d square y by dx square at the point 3a by 2 comma 3a by 2 will be, so y square, 3a by 2 whole square is 9a square by 4. So we have 9a square by 4 minus, see, a into 3a by 2. See, we have here a, so 9a square by 4 into 3a by 2. Okay, that becomes 3a square by 2. Bracket close. Again minus a. Why minus a? Because dy by dx is minus 1. Minus again 2 into 3 by 2. 2 cancels. We get 3a minus a into y. A into y. That is a into 3 by 2 is 3a square by 2 minus again 9a square by 4. Then 2y divided by dx. What is y again? 3a by 2. See, 2 into 3 by 2. 2 cancels. We get 3a. And divided by dx is minus 1, so minus into minus upon. So what is this? Y square minus x the whole square. What is y? Y is 3a by 2. The whole square is 9a square by 4. You need to be first. Minus a into 3a by 2 will be 3a square by 2 the whole square. So now let's simplify this. Okay, so this will become now how much? LCM is 4, 9a square minus 2 to the 4, 6a square minus 4a minus again 4, 6a square minus 9a square minus 4a whole divided by, this becomes whole divided by, this is 4 here, whole divided by, this LCM is 4, 9a square minus 6a square the whole square. So this will be now 4 cancels. Okay, so what is 9a square minus 6a square? It's 3a square. So this will be minus 3a cube. Am I right? Minus 6a square minus 9 is again minus 3. So again minus 4 cancels here. again minus 3a cube divided by, this will be 16, and again 9a square minus 6a square is 3a square. So 3a square is 9a raised to 4. This is what we have. Okay, so that means if you simplify this, we get this as nothing but 16 into minus 6a cube divided by 9a raised to 4. Okay, now 3 3s are 9, 3 2s are 6. So a cancels, we get minus 32 by a. That means the radius, the d square y by dx square at 3a by 2 comma 3 by 2 is how much? Minus 32 by a. Now since we got both dy by dx and d square by dx square at the point 3 by 2, 3 by 2, now we know the formula. So the radius of curvature is rho is equal to 1 plus dy by dx the whole square raised to 3 by 2 upon d square y by dx square. So that will be 1 plus minus 1 the whole square is 1 raised to 3 by 2 upon minus 32 by a. That becomes a. See this minus 32 by a goes top. So a by 32 and 2 raised to 3 by 2. So this is the answer. Okay, that is right clearly here 2 raised to 3 by 2. This is the answer. But we can still write this answer in a more standard form as, so see, a, so this will become nothing but, I write here a into 2 raised to 3 by 2 is written as what? 2 into root 2. Why? Because see, 2 raised to 3 by 2 is 2 into 2 raised to 1 by 2. That is, okay, I hope you're getting it. 2 into 2 raised to 1 by 2 is 2 raised to 3 by 2 upon 32 is written as 16 2s are. Again 2 cancels. Okay, again this becomes nothing but, we have a into root 2 divided by, again 16 is there. What is 16? 16 is 8 2s are 16. So I'll write 8 into 2 as root 2 into root 2 cancels. So answer is a by 8 root 2. Therefore, the radius of curvature is nothing but, that implies rho is equal to a by 8 root 2. And this is the answer. And radius of curvature is always positive. That's why I have not taken the negative sign here. That's it. Even if it's negative, it becomes positive. That's the solution for this problem. So the solution, that is the radius of curvature for the folium of Descartes x cube plus y cube is equal to 3xy at the point 3 by 2 comma 3 by 2 is nothing but how much? We have it here as a by 8 root 2. That's the answer. I hope you understood the problem, but you need to practice this a lot. Okay? Fine. The next problem which we are going to discuss is, find the radius of curvature of the curve root x plus root y is equal to root of a when the curve cuts the line y is equal to x. They can also mention in this question the point passing through origin making angle 45 degrees to the x-axis. It's obvious that when the curve cuts the line y is equal to x, the line y is equal to x passes through the origin, so it will make 45 degrees to the x-axis. So both are same. So now let's solve this question. So as you know, in this question, they are not given the point of intersection, but see, they are given the curve cuts the line y is equal to x. That means we know that y is equal to x. So putting in the question, we can find the point of intersection. Right? So let's do that. So we have the question root of x plus root of y is equal to root of a. So putting the point y is equal to x here, we get root of x plus root of x is equal to root of a. That is 2 root of x is equal to root of a. Square this, 4x is equal to a. That is x is equal to a by 4. So y is also equal to a by 4. Why? Because y is equal to x. Therefore, that implies we have the point of intersection as a by 4 comma a by 4 as points of intersection. So, I already found the points now. Now, we need to find the radius of curvature. As we have discussed in the previous problem and the previous theory also, the radius of curvature of a Cartesian curve. Why Cartesian? Because see, in the question they give x and y. So, x and y means Cartesian. So, for the Cartesian curve, the radius of curvature formula is rho is equal to 1 plus dy by dx square whole raised to 3 by 2 upon d square y by dx square. That means, we need to first find dy by dx, put the point, then find d square y by dx square, put the point, put in the formula, get the answer, right? So, let's do that here. So, we have root x plus root y is equal to root of a. I take this as 1. So, now I differentiate with respect to differentiate 1 with respect to x. Okay. Now, if you differentiate 1 with respect to x, differentiation of root x is 1 by 2 root x plus differentiation of root y. See, we are differentiating here with respect to x. Okay. So, but if it, since we x means x is differentiation, root x will be 1 by 2 root x, but differentiation root y will be 1 by 2 root y into dy by dx is equal to root is constant 0. So, that implies from here we can find dy by dx is equal to, taking this side, so 1 by 2 cancel, let's go this side, and root y will go up to become minus root y by root of x. Fine. Therefore, dy by dx at the point a by 4 comma a by 4 is equal to, if you put here we get minus 1. So, we get dy by dx as minus 1. Now, the next thing is we need to find d square y by dx square. So, let's differentiate this again now. So, what is dy by dx I got? Minus root y by x. So, again if you differentiate this, so what we get here if you differentiate? This will be quotient rule. So, d square y by dx square will be, what is quotient rule? Quotient rule is numerator by denominator. So, I will discuss in a very simple way, like how you know differentiation of first by second function will be second function square, second as it is, differentiate first, minus first as it is, differentiate first, differentiate second. A very easy way to remember the quotient rule. So, if you apply that, we have root x square, root x square, root x as it is, that is first by second, second square, second as it is, differentiation of first function. So, what is differentiation root y? It will be 1 by 2 root y into dy by dx minus the second, the first function as it is. So, root y will be as it is. Okay. So, what I will do here, this is there is a minus sign here. So, what I will do, I will take minus outside. I write this. Okay. D square y by dx square is equal to minus bracket. I will take. Why? Because there is a minus sign here. That's why. Okay. Now, see, root y as it is into differentiation of second function. What differentiation of this root x? 1 by 2 root x into, yeah, that's it. Fine. Now, we already know that dy by dx is minus 1, right? So, we put that here. That means, if you find, therefore, d square y by dx square at the point a comma 4 comma a comma 4 will be how much? So, see here, root x by root y. See, both are same. Root a by 4, root a by, it will be 1 only. So, I get 1 by 2 into, what is dy by dx? Minus 1. Minus again. So, I not taken the minus outside. Yeah, minus outside bracket. Fine. Now, this will be minus again 1 by 2. Fine. Upon this will be root x square will be root of a by 4 the whole square. That becomes minus 1 by 2 minus 1 by 2 plus minus 1. So, minus minus plus 1. So, 1 upon we get a by 4. Okay. So, a by 4, that is nothing but 4 by a. Therefore, we have found dy by dx and both dy by dx and d square by dx square at the point a by 4, a by 4. Therefore, the radius of curvature rho is equal to 1 plus dy by dx square whole raised to 3 by 2 upon d square y by dx square. So, if you do that, put the values here. So, 1 plus 1 square raised to 3 by 2 upon, because dy by dx is minus 1, minus 1 square is 1 only, upon 4 by a. So, that comes to be how much? 2 raised to 3 by 2 upon 4 by a. That will be 2 raised to 3 by 2 now can be written as. So, this is the answer, but there are ways to simplify to bring to some standard form. So, 2 raised to 3 by 2 is 2 into root 2. Why? Because 2 into 2 raised to 1 by 2. 1 plus 1 by 2, 3 by 2 up into a upon 4. 2 1s are 2 2s are. So, again, this can be written as root 2 a upon, see, 2 can be written again root 2 into root 2. Cancels, we get a by root 2. Therefore, for this curve, the radius of curvature is, that implies rho is equal to a by root 2. That's the answer. So, the radius of curvature for the curve root x plus root y is equal to root of a at the point a by 4 comma a by 4 is nothing but rho is equal to a by root 2. That's it. Fine. Well, in today's video, we solved some problem based upon radius of curvature for Cartesian curve. Please do refer the next video for more set of problems on Cartesian curves. Till then, stay tuned, keep watching. Bye.